Hi everyone and welcome. We're so excited to have you here as you start your journey towards New York City Specialized High School Admissions Test SHSAT. In this video, we're going to be covering a math lesson which is going to build the foundation you'll need to get a top score in your exam. Before we begin, make sure to have a pen and a notebook ready with you so that you can note down all of the different tips and tricks that we are going to be covering in today's lesson. Also, if you cannot afford expensive tuitions, don't worry. Our free lessons and app practice are designed to help you boost your confidence and also get a very good preparation of the exam without the high cost. Plus, our app provides predictive tests, which is going to give you a feel of what the SHSAT exam is really going to feel like. Now let's get started and take the first step into getting into one of New York City's specialized high schools. So in this lesson, we are learning how to identify rational numbers and irrational numbers. Of course, we are going to go through what each of these terms really mean. Also, how to convert recurring decimal numbers, basically the decimals that continue, and also fractions. We're also calculating absolute values, PEMDAS, sequence, and also involving number lines. So there's a couple of different topics as you can see here. Let's start. In the very first question, A equals, we have a couple of numbers here in a set, right? So the question says in the set A, which number is not a rational number? We should first of all know what a rational number is, okay? A rational number is basically a number that can always be formed in the format P over Q, okay? So in that case, P and Q are both supposed to be integers, as in they're both supposed to be whole numbers. And the value for the denominator here, which is Q cannot be equal to 0. You know why? Because let's say if we do any number divided by 0, what will the answer be? The answer will be infinity. So infinity is once again an irrational number. So it's not a rational number. So let's look at the numbers, okay? So the following are rational numbers. Basically, if we consider the first one, any sort of integer or a whole number is a rational number, okay? For example, in this case, we have 5. Look at the first number here. 5 is an integer, so that is a rational number. Number 2, fractions can also be rational numbers, okay? Not fractions with the denominator of 0, by the way. So as you can see, the second number being 3 over 5, this is of course a rational number. At the same time, mixed numbers can also be a rational number, okay? Any sort of mixed number, let's say if we do 5, 3 over 5, that's a mixed number, but we know that that is not a part of the question here, but I'm just still writing it down so that you can note it down which ones are rational numbers and which ones are not, okay? At the same time, repeating decimals are also rational numbers. So repeating decimals are the ones which has a sort of like a hyphen symbol on top of the number. So let's say if we have 6.32 here like this, like the question, on top of the 32 we have a sign like this, right? What that means is the value is 6.323232. So this is continuously going on and on and on. So this is also a rational number. At the same time, if it's not a repeating decimal, then it will be called a terminating decimal. So essentially, terminating decimals are the numbers that we just consider them to be basic decimals without that extra symbol up top. So if we look at the question, we have 6.2 here, right? Without that other sign. So that is also a rational number. And at the same time, if it's a perfect square, by a perfect square, I mean any number which, when you make a square root of it, it will give you an exact result. For example, if you have square root of 16, like the very last number that's given in the question, what is square root of 16? It's either plus 4 or minus 4. Why? Because 4 squared is 16, and at the same time negative 4 squared is also 16. So 16 is a perfect square. However, if you consider this particular number right here, root over 3, if you use a calculator, root over 3 is going to be a very, very continuous number. But even if we don't use a calculator, if you just think about it, if you think about square root of 4, that is of course 2. If you think about square root of 1, that is 1. So all the numbers in between, square root of 2 or square root of 3, these are all not rational numbers. Why? Because when you do square roots of these, you are not going to get a single integer or a single digit.
the number is going to continue on and on and on, which means that square root of 3, according to the question, is our answer. Okay, this is the number that's not rational. Got it? Let's move on. So here we have another set. In this set, which number is not an irrational number? So it's just that you do need to remember everything that we have learned about rational numbers before we do this. So first of all, if it's an irrational number, what are the rules that we need to remember? Yeah. So first thing is, of course, if it's p over q, the denominator cannot be 0. So let's take x and let's take a denominator as 0. That is an irrational number. You can never do that because the answer is going to be infinity. Another one is if you do square root of a non-perfect square number. For example, square root of 2, square root of 3, or in this case, look at the first number, square root of 5. These are all what? These are all non-perfect square numbers because they're not going to give you an exact value after you do the square root of it. So that means it's irrational. Okay, number 3. Also cube roots. Cube roots of a non-perfect cube. So if you do cube root of 2, what's going to happen? Cube root of 2 will not give you a perfect answer, but because 2 cubed is 8, if you do cube root of 8, that's going to be 2. So that is a rational number. But because in this question, do we have any cube roots? We don't, but it's just still given. Like I'm still helping you out with this so that you do understand what are irrational numbers, okay? So any sort of cube root or any other higher power, let's say if you do to the power 4 root, once again, this is not going to be a rational number, okay? And also some, numbers like pi, because pi has a value of 3.412 and then the numbers continue. Also, if you have exponent, if you once again want to know the value for an exponent, it's 2.718281828. So once again, these are numbers that continue on and on and on. So these are all irrational numbers. So now let's just look at these numbers. We know square root of 5 is for sure an irrational number. Well, how about 1 over root 2? Once again, because root 2 in itself is irrational, so even if you do 1 over root 2, it's still irrational. What about 3 root 5? Because root 5 is irrational, 3 times root 5 is of course irrational. What about root 9? Okay, if you look at root 9 here, we know that if you do 3 squared, you're going to get 9, which means that the value for 9 is plus 3 and minus 3. You know why it's minus 3? Because even if you do negative 3 squared and if you put a square root on top of it, it's also going to give you square root of 9. So root 9 is our answer, which is not irrational because this is of course a rational number. This is of course a perfect square. Okay, moving on. Show that square root of 8 squared plus 9 squared is not a rational number between which two consecutive positive integers is square root of 8 squared plus 9 squared. Okay, so first of all, let's just do square root of 8 squared plus 9 squared. Okay, square root of 8 squared is 64, square root of 9 squared is 81. If you do the math, if you add them both, it's going to be square root of 145. Now 145 is not a perfect square number, which is shown that this is not a rational number. How did we know that square root of 145 is not a perfect square number? That can also be one of the questions, right? Because if you think about numbers from 10, okay, what is 10 squared? 10 squared is 100. 11 squared is 121. 12 squared is 144. Again, if you do 13 squared, that's 169. So if 12 squared is 144, then just a digit above it, square root of 145 is of course not going to be a perfect square number. That is exactly how I understood, okay? So now what does this mean? If 12 squared is 144, this means that square root of 144 is one of the rational numbers, and at the same time square root of 169 is one of the rational numbers, right? So the question asked between which two consecutive positive integers is this. So whatever we see here, square root of 145 is of course in between square root of 144 and square root of 169, right? So between which two consecutive numbers are these? They are in between 12 and 13, okay? So your answer is going to be, it's between 12 and 13 is the square root of 145 according to the question. Okay. Moving on, here's a practice question for you which tells us, here's a set as we can see. Make sets B with all rational numbers and set C with all irrational numbers from set A. Okay, so practice questions are there on every different lesson so that you can practice by yourself. You can see whether you do get the answers correctly. So take a screenshot of this and do it on your note copy, or you could also pause the video and do it. After you're done, let's move on with a new topic, okay? Moving on. So as we can see, we have a recurring decimal here. Just like I said in the very first question, if you have a recurring decimal, if you have something with a sign like this, what that means is there are continuous digits. So it's 0.33333 all the way along. So that means it's 0.33333 continuously, right? So if you now do the math, what's 0.3 times 0.3? If I just did 0.3 times 0.3, what will my answer be? So there's one way of doing it, which is the lengthier one, but let me show you an easier one. What is 3 times 3? Of course it's 9, but because it's 0.3 and 0.3, how many numbers do you have right next to the decimal? You have one number here next to the decimal, you have another number here next to the decimal. So in total, there are two numbers next to the decimal, right? Which means that at 9, because we don't see any decimal with just the digit of 9, we will imagine that there is an imaginary digit next to the number 9, okay? So if it's 9, it means 9.0, 9.000, they all mean the same. 2, 2.0, 2.00, they all mean the same. So if there is an invisible digit, if there's an invisible decimal next to the number 9, we can now take the digit, the decimal 2 units up front and put the decimal here. The new decimal goes here. So now what happened is, right in front of 9 there is a blank space where we can put a 0 here and we can put another 0 here. So your answer is 0.09. But because you're multiplying with a lot of different trees, your answer is 0.099999 and whatnot. So if you would like to give your answer in a recurring decimal, your answer would be what? 0.09, and on top of the 9 you put a sign like this, which represents that there are continuous 9s. So here we see how to convert our recurring decimal to a fraction, right? So let's consider x to be 0.6, and I'm gonna put this sign on top. So the value for this is going to be 0.66666 and so on. Okay, so if x is this, now what I can do is, let's first put 10 on both the sides. You know why I'm putting 10 on both the sides? Because there is only one digit on top of which is that sign, okay? Had there been 2 digits on top of which we are going to see the recurring decimal sign, we would have multiplied 100 with both sides, okay? So just hear me out. Let's just look into the entire thing and then it's going to be very clear in your head. So in the case of 0.666, now I'm going to multiply 10 with it, right? So now what? Now that's 10x equals, if you multiply this, it's going to be 6.666 and so on, right? Now what? Now I have to subtract x from both of these ends, as in subtract the very initial number from this. So I'm going to do 10x minus x, and at the same time I'm going to do 6.66 minus 0.66, which was the number to begin with, right? Of course with a lot of different continuous numbers, but let's just take 2 digits. So what that means is 10x minus x is 9x, but here we are actually eliminating the decimals completely, and that was my main target, okay, to eliminate the decimals, which is why I went through all of this. So 6 minus 0 is 6, but 0.66 minus 0.66 is going to cancel each other out. So if 9x is 6, then x is going to be 6 over 3, 6 over 9, and of course if you cancel them out, 6 over 9 cutting them out is going to be 2 over 3, which is your final answer, okay? Let's look at another one with 2 digits, like I said before, okay? If you have 2 digits, my first step is of course going to be x equals 2.353535 and so on, right? Now if I want to take away the decimal part, what I'm going to do here is I'm going to multiply 100 with it. Same here. So if you multiply 100 with this, what's going to happen is automatically, because 100 has 2 zeros, now it's going to be 2 units to the right. So what that means is 235.3535 and so on. Once again, what we do here is we subtract. Remember, we subtract 100x with x, and again we subtract 235.3535 from the original number, which was 2.3535, because we need to get rid of the decimal. 100x minus x is 99x. 235 minus 2 is 233, but we just got rid of the decimals. So now it's going to be x equals 233 over 99. You can leave your answer like this, or you can write it in a mixed number format, 235 over 99. Okay, moving on. We are now going to convert this particular recurring decimals to one fraction. So you have 2 decimals to think about. Let's do both of them, okay? We are supposed to do both of them individually, and then we are going to divide them. So what this means is, of course, 0.055555 and so on, right? So do you remember what we do? What we do here is, of course, we take x equals 0.0555 first of all, and then now what we can do is we can do it in 2 different steps. Let's first take 10x. Of course, taking 10x means you need to put the decimal 1 unit to the right. So now it's 0.55, right? I think that kind of looks like a sign, so I'm just getting rid of it. I'm just writing the 0 clearly because I just put the decimal 1 unit to the right. So it's 0.555, so on. But now I'm going to also take 100x, and that will cause the decimal to move 2 units to the right. So first of all, it moved 1 unit, and now it's going to move 2 units to the right. So now it's 5.55 and so on, right? And now what? Now we are going to do 100x minus 10x equal to 5.55 minus 0.55, okay? So if you do that, 100x minus 10x is 90x. And of course, now we can get rid of the decimal. So that means it's a 5. So x equals 5 over 90. So we can just simplify it, and it's going to be 1 over 18. So that is it for just the first numerator. We're going to do the same with the denominator here, okay? So let's just take that as y. So y equals 0.2777. The numbers will now continue, right? So once again, just like I did for x, I'm first of all going to do 10y, which is going to put the decimal 1 unit to the right. So that's 2.777. And now I'm going to do 100y, which once again turns it to 27.777, right? Now what? Same steps here. I'm going to do 100y minus 10y, which is going to be 27.77 minus 2.77, which will be 90y equals, getting rid of the decimals, so that's 25. And finally, if you now do y equals, it's going to be 25 over 90, which is basically 5 over 18. Okay, don't mind that. So that's going to be 5 over 18. So now what? Now you have 1 over 18 in the numerator and 5 over 18 in the denominator, which basically means 1 over 18 divided by 5 over 18. The 18 and 18 is going to get cancelled out. So that is just 1 over 5, which is my final answer. Okay? All right. Moving on to the next part. So here we have another practice question. I hope that you do get the answer correctly, which is 8 over 33. You can also keep your answer as oh, you're supposed to keep your answer as an improper fraction, by the way. So because the answer has already shown you a mixed number, that is not the exact way in which you should keep your answer. Your answer should be 74 over 33, okay? So I hope that you do get 74 over 33. Let's move on to the next topic. We have modulus here, okay? Absolute values, or we can also call them modulus. So absolute values means that whenever you have a negative number inside an absolute value, it's going to turn to a positive. And of course, if it were a positive to begin it, it will remain as a positive. So because you have negative 25 plus 13 here, let's do what's negative 25 plus 13. Negative and positive means negative. The sign 25 is bigger, so it has a negative sign in the front, so we are going to put the negative sign. 25 minus 13 is 12. So negative 12 being inside an absolute value is just going to be positive 12, okay? That's your final answer. Here we have a much more complicated one. It looks complicated in the beginning, but let's just break everything down, okay? So for A, you have a negative here. Inside you have a modulus, again a negative sign, again a modulus. So let's just first get rid of the modulus signs, alright? So taking the minus as it is, now what you do here is just get rid of that modulus sign with the minus 3. So it's just going to be 3. Again, there's a minus outside. With the minus 12, now it's just going to be just a 12. So what's minus 3 minus 12? It's minus 15, right? But the question asked for, what is minus of minus A? So if I now put it here, it's minus of minus 15. See, so this is where the students might make a mistake, because A was negative 15 to begin with. And now, if I just break the first parenthesis, so negative and negative makes positive, so that is minus modulus 15, which of course will just give you an answer of minus 15, because the minus sign was outside of the modulus, not inside. Had it been inside, the answer would have been positive 15. Moving on. We have another practice question here. I hope that you do get 4 as your answer. Okay. Yeah. So here we have the concept of PEMDAS. We learned about it in school. Let's give a short revision. PEMDAS means that first of all you should do the parentheses, and then as you go on you should do the divisions, you should do the multiplications, then the divisions, then the additions, and then the subtractions, okay? So first of all, let's do whatever we see inside the parentheses. So we have 15 minus 5 inside the parentheses. Let's just do 10 here, divided by 2 cubed, plus 14 minus 4. Once again, this is going to be 10 here times 2. Now what? Now we should multiply, right? So 10 divided by 2 cubed is basically a multiplication, because that means 2 times 2 times 2, which is 8. Again, we have 10 times 2, which is another multiplication, which is 20. Now we should divide first. So dividing 10 over 8. Yeah? So 10 over 8 is what? 2 times 4, 2 times 5. So that's 5 over 4, which is actually 1.25. So 1.25 plus 20, we only need to just add this now. So that's 21.25, my final answer. Okay. Here we have another one. We have first parentheses here, and we also have brackets here. So first of all, break the parentheses and then you break the brackets. So let's see. We have 6 plus 8 times, inside the parentheses we have 15 minus 20, which is what? Which is negative 5, divided by, we can just put 2 squared as it is, because it won't really matter. So 2 squared, so whenever you see any powers, you can just do the powers in the very first step. So 2 squared is 4. Now what we do is, first of all, you do everything that you see inside the parentheses, right? So inside the parentheses, I see multiplication, 8 times negative 5. So I'm going to do that first, which is negative 40 divided by 4 minus 36. So now I'm going to do negative 40 divided by 4, which is negative 10. So 6 plus negative 10, negative 36. Now what you do is to break the parentheses. Outside the parentheses you have a positive, inside you have a negative. So these two will mean positive and negative will be negative. So that's just 6 minus 10 minus 36. Now if you think about it, we do the addition first, remember? So negative 10 and negative 36, negative and negative means positive. So minus 10 minus 36 is actually minus 46, right? So I'm going to write 6 minus 46. And finally, if you do 6 minus 46, the bigger one has a minus sign, so it's going to start with a minus sign. 46 minus 6 is 40. So your final answer is minus 40. Okay, now we have another one. Let's just start. We have 100 over here. We have 0.002. Oh, we have modular signs. We should also think about the modular signs as well. Okay, and then we have plus minus 0.04. So if you want to, we can just get rid of this bracket, this parentheses here. So positive and negative means negative. So I'm going to do negative minus 0.04. And then you have a negative sign here, and you have negative 0.1 whole cubed. So what does that mean? 0.1 whole cubed, what does that mean? That means 1 times 1 times 1, which is of course 1. But you remember what I showed you? If you have 0.1 to the power of 3, that means 0.1 times 0.1 times 0.1. So for each of the numbers, you have one number next to the decimal. In total, you have 3 numbers next to the decimal. So in the case of 1, if there's an invisible decimal here, you put it 3 units to the left, 1, 2, 3. So you now have a decimal here, you fill in the gap with 2 more zeros. So that's 0.001, right? But before that, you had a minus sign. So before the 0.001, you had a minus sign. And see, you had another minus sign here to start off with. So minus 0.001 is basically plus 0.001. Okay? Then you just get rid of this bracket. Okay, now of course inside the bracket we are supposed to do addition first, then subtraction. So if you do 0.001 minus 0.04, if you do 0.001 minus 0.04, that is minus 0.039. So we are going to write 0.002, and here that is minus 0.039. And once again, if you do the math inside the bracket, it's going to be minus 0.037. Okay, so now what? Now that you have 100 here, just like this, of course, multiplying this to this is going to be what? That means 0.037. You're multiplying it with 100, which means it's going to go 2 units to the right. So your answer is going to be 3.7, but you have a negative sign. And the negative sign is in between the modulus, which of course means your final answer to this is positive 3.7. Okay? Let's move on to the next question. We have another practice question here. I hope that you do get the answer correctly, which is going to be 37. Moving on. So here we see 2, 6, 22, 86. The question says the rule for continuing the sequence is multiply by A, then subtract B. Find the next 2 terms. Okay, so that means if we consider the first number, 2, we have to multiply 2 with A, which gives us 2A, and then subtract B, so minus B. If I do that, it gives me the next number, which is 6. Again, if we take the second number, 6, if I multiply that to A and I subtract B, it's going to give me the third number, which is 22, and so on and so forth. So to figure out the next 2 terms, what we can do is we can first of all solve this simultaneously according to simultaneous equations. So there are a couple of ways in which you can do it. You can use the elimination method, the substitution method. I'm going to show you the easiest one. So what I do is whenever I see different types of variables like this, I first of all have to figure out a way in which I can cancel out either of these variables. If you can see, you have A and B here. With A you have coefficients, but with B you do not. So let's try to figure out what I can do with B. To cancel out B, that's going to be easier because it's negative B in one side, and with the other negative B, if I can convert it to a positive B, of course, I would be canceling out the negative B and the positive B. Because I've just changed the sign of the second line, I have to change the signs of all of the ones in the second line. So plus 6A will now be a minus 6A, plus 22 will now be a minus 22. So 2A minus 6A is minus 4A, and 6 minus 22 is minus 16. Now if you solve for a, it's going to be negative 16 over negative 4. Cancel out the negatives. 4 times 4 is 16, which means a is 4. If you now put a equals 4 in the first equation, or any equation in that instance, so you can write 2 times a, so 2 times 4 minus b equals 6. Now 2 times 4 is 8, so let me just write 8 minus b equals 6. That makes it minus b equals 6 minus 8. 6 minus 8 is minus 2. Cancelling out the minuses gives me b equals 2. To figure out the next two terms, what do I do? For the next term, because we already have 86 here, so what should we do? I should do 86 times a minus b, right? So that means 86 times a, which is 4, minus 2, which gives me 342. Again, for the next term, I need to do 342 times a minus b. That makes it 342 times 4 minus 2, which gives me 1366. So these are the two terms that's asked in the question. Moving on. So here we have another sequence. Negative 3, 2, 5, negative 3, 2, 5, negative 3, 2, 5. So as we can see, this pattern is actually continuing, right? So we can say that negative 3, 2, 5, this is the repeating unit. The question says the sequence above continues according to the pattern shown. What is the sum of the first 50 terms of this sequence? So if you think about it, it's going to go on and on with 3, 3, 3. So for the third term, it's 5. Again, for the sixth term, it's 5. For the ninth term, it's 5. So because it's saying for the first 50 terms, let's figure out the multiples of 50, the multiples of 3, which are less than 50, okay? So the multiples of 3, which are less than 50. So if we go on the above numbers, like does 3 times anything make 50? No. Does 3 times anything make 49? No. What about 48? Yeah, I think 48 and 3 gets divided with one another. If I do this very shortly here, 3 times 1 is 3, 1 and 8, so 3 times 6 is 18. So therefore you can say 3 times 16 is 18. What that means is till the 3 times 16 is 48. So what that means is the 48th term is of course 5. So the 49th term is going to be negative 3, right? The 49th term is going to be negative 3. Again, the 50th term is going to be 2. So what I can say is for the first 50 terms, there are in total 16 numbers with the patterns of negative 3, 2, 5, right? So can I say negative 16 times minus 3 plus 2 plus 5? So I can say 16 times minus 3 plus 2 plus 5 to figure out the total summation of the first 16 terms. But for the 17 and for the 18th terms, what I can do is I'm just going to do the 49th term as negative 3 and the 50th term as 2. Now all you have to do is add everything up. So negative 3 plus 2 is negative 1. 5 minus 1 is 4. 16 times 4 is 64. So it's 64 minus 3 plus 2. 64 plus 2 is 66. 66 minus 3 is 63. That is your final answer. Okay? Let's look at the next question. We have another practice question here. As you can see, once again, this is a repeating unit of 1, 2, 3. So I hope that you do get the answer correctly, which is 132, as you can see here. Okay. If it is now 5 a.m., what time was it 52 hours ago? So as we already know, the time is exactly the same. 24 hours, right? Like it's always like 24 hours after one another, the time is same. So if the time is, let's say, 8:50 now, 24 hours later is again going to be 8:50 p.m. So it's going to be, if I want to convert 52 hours into, in the 24-hour format, what it's going to mean is, how many 24 hours does 52 have? If you think about it, 52 is basically 24 plus 24, which is 48, plus how much more? 48, 49, 50, 51, 52, plus 4 more hours, right? So 52 hours ago, or if I want to say, what was 48 hours ago? 48 hours ago, it was 5 a.m. But if you go further 4 more hours, it was what? It was 1 a.m., right? That is my answer. So here we see on the number line above, AB equals 2.5, AD equals 5 and 5/6, and CD equals 1 2/3. So what is the position of point C? So first of all, let's see, because AB is given as 2.5, if I want to figure out the value for A, what I can do is, as I can see, that B is 2 and 1/3, so I can write B minus AB to figure out the value for A, right? So B till B, it's 2 and 1/3, and AB is 2.5. So let's just do the math here. To convert the improper fraction to, to convert the mixed number to an improper fraction, I first have to multiply 2 and 3, which is 6, plus 1, it is 7. So it's 7 over 3 minus 2 times 2 is 4, 4 plus 1 is 5. So that's 5 over 2. Now I have to make the denominators the same. So to do that, I'm going to multiply 2 here and 3 here. And you multiply the same number you just did with the numerators. That gives me 14 over 2 times 3 is 6, minus 15 over 6. 14 minus 15 is minus 1 over 6. Here we just did point A. Now for AD, if you want to know for AD, first of all, what I can do here is, because the question said to figure out point C, so let's just figure out point D first, okay? Instead of AD, let's just figure out point D first. So D is going to be, the first of all, we figured out A, so you can write A plus AD. So A was minus 1 over 6, and AD, as you can see in the question, it's 5 and 5/6. So 5 over 6 can be converted as what? 6 times 5 is 30, 30 plus 5 is 35. So now, because the denominators are the same, all you have to do is just, you will be just dealing with the numerators right now. So that is minus 1 plus 35, which is 34. So 34 over 6, or if you further simplify it, that's 17 over 3. Now that you know what D is, we can now figure out C. So before we do that, what is C? C can be D minus CD. So D is 17 over 3, just like we did now, and CD is 1 2/3. So converting 1 2/3 to an improper fraction will mean 3 times 1 is 3, 3 plus 2 is 5. So all you now need to do is to simplify 17 over 3 minus 5 over 3. Just do 17 minus 5, which is 12 over 3. So 12 over 3, if you further simplify, that is 4. Here you have another practice question. I hope that you do get this correct answer. And with that being said, that is the end of lesson 8.
And with that being said, that was the end of this particular lesson. Hope you did really enjoy it. Most definitely leave a comment below to know how we can improve ourselves. And at the same time, if you did enjoy all of the maths that we have already covered throughout this lesson. At the same time, if you cannot afford really expensive one-on-one tutoring and personalized tutoring, here's a solution for you. You can actually download our SHSAT Prep app from Apple App Store. It has a lot of practice materials for you, and at the same time there's also a predictive test which is actually going to give you that real feel of attending an exam. Thank you so much for watching. Make sure to leave a comment below and practice well for your exam.